Continuing with section 3.1, let us look at another example where we are given the function g of t is equal to negative 5t squared plus 4t minus 3. So notice here the coefficient of the square term is now not 1, it is negative 5. So when you have this situation, when your a is not 1, then I would recommend this method. There are slightly different method as well, which most teachers do adopt that, but I think this one is, I feel like this one is easier to understand what's happening. And what I'm going to do here now, I'm going to factor out the negative 5 from all the terms. So we write negative 5. So when factored out from the first term, it gives us just t squared. Then what happens? What do I get next? Well, I have, the term is 4t. What I'm factoring out is negative 5. So I will divide the term by negative 5. So I get negative 4 over 5t. And then I have the next term is negative 3. So divide by negative 5, we get plus 3 over 5. Okay, so now we will do the, if you notice the inside function here, this is the same as we were doing with the 1 in front of that square term. So we will treat it the same way and do it the same way. So we have negative 5, keeping negative 5 outside. Inside we will do the work that we have been doing. So t squared minus 4 over 5t. So now from this term with the t only or x only, so this is coefficient of that term, which is 4 over 5, is going to give us the m term. So we divide it by 2 or we multiply it by 1/2. So we get 2 over 5. That is what we need to add. So this is our m. So recall what I mean is the m, for the m square we add here to complete the squares. Also you can think of it like this, that this is 4 over 5. So we can think of 4 over 4 as 2 times 2. So I can write it as 2 times 2 over 5. So if you look at this term, this is, this term, this one. So 4 over 5t can be thought as 2 times 2 over 5t. So the t is for the x, 2 is for the 2, and the middle, this is your m. So divide by 2 or pull out the 2 from the middle term. That gives you what you need to add. So you need to add 2 over 5 whole squared. Now whatever is left, which is plus 3 over 5, and now we have to subtract that term that we added. So minus 4 over 25. The square of 2 over 5, 4 over 25. Now just as usual work. So is equal to negative 5. Now this can be written as this. These three terms give me t minus 2 over 5 whole squared, and then plus. So now I have to simplify these two terms by taking the common denominator, which is 25. So I end up getting 15 minus 4. So is equal to negative 5 bracket t minus 2 over 5 whole square plus, so this gives me 11 over 25. Now we distribute the 5. So we get negative 5 times t minus 2 over 5 whole squared minus, when I multiply 11 over 25 by negative 5, because 5 goes into 25 times and we are left with negative 1. So we get negative 11 over 5. So we can see that vertex is 2 over 5, negative 11 over 5, which is actually equal to in decimal. We need to have it in decimal because for graphing purpose, it's easier to plot the decimal points. So 0.4, comma, negative 2.2. Okay, so that's what we get as a the vertex. Now note here that the vertex is below the x-axis, and because of the leading term, so lead term is lead term means the term with the highest degree of the variable. So it's negative 5t squared, or you can say our a is equal to negative 5, which is less than 0. So our parabola is open down. So we have vertex is this and parabola open down. So it means we do not need to find the x-intercepts because the graph is never going to cross the x-axis. So even if you try to find them, you will see that you get complex numbers. So you say that the x-intercept do not exist. So what we do now is we can find the y-intercept. So y-intercept, which is pretty easy, we just plug in 0 for the t, and so the t-intercept, which will be similar to what we say x-intercept, will do not exist. So y-intercept, y will be equal to negative 3. Okay, let's now try to graph the function. So I don't need to leave much space on the top or above x-axis because the function doesn't go there. It doesn't go across the x-axis and go above. So I have negative 2, negative 4. Maybe I'll just put 1 here. 1, 3. Maybe that's enough. Negative 1, negative 2. Okay. So so this time it's t-axis, not x-axis. Okay. This will be t and this will be y. So the vertex is 0.4 and negative 2.22. 0.4 somewhere here. We go down 2.2 somewhere here. This is vertex, and the y-intercept was 3, which makes sense. It will cross here 3, negative 3, and then by symmetry, you can see this is the axis of symmetry. So by symmetry, this distance is 0.4. So then a distance of 4 from here, which means 0.8, the value will be negative 3 again because of symmetry. Okay, so if you want, you can now figure out what is the value at negative 1, and then you'll get a same value at, so that negative 1 will be at a distance of 1.4 from the vertex. So we go 1.4 to the right side, which means it will be 1.8. So you will have the same value. So now when you graph the function, you will notice that the graph is very thin graph, like a thin parabola. Okay? And the reason is that number 5 being multiplied. So this type of translations we haven't done because these are what we call non-rigid translations, because transformation, sorry, because they stretch or expand the graph of the function. So our normal graph would be that from the vertex 1 unit to the left, you will be 1 unit down here. 1 unit to the right, you will be 1 unit down there. But here, you see, we are not going 1 unit. We are going less than 1 unit, and we are going a little less than 1 unit down. So this is the parabola. So what is the domain? Negative infinity to infinity, and range will be negative infinity, so parentheses here, to the 11 over 5 or negative 2.2. So that will be the range. So this is how you work with these quadratic functions. Next, we will look at polynomials in general in the next section.